Hello students, Ms. Slyman here, and in this set of notes we're going to discuss the idea of linearization. So first of all, let's define this. Linearization is a type of approximation where I use lines to approximate values on a curve. So let me make this font a bit smaller. So this is a process using lines to approximate values on a curve. All right, so we've seen tangent lines before, and now we're going to put a context and use for tangent lines because there's a reason that we have tangent lines, and this is really it. We use them to help approximate values. So here's a graph of f of x. We're going to sketch the tangent line at x equals 3. So here's my x value of 3. I'm going to put in a tangent. So I'm going to put this tangent. The question is, do I put the tangent above or below the curve? And it looks to me like it's going to fit better below the curve, and that's because at this point in my graph, my curve is concave up. So it's better to have the tangent underneath it, and that's because I want my tangent to intersect at just one point, and if I was above it, it would go through more quickly. So I'm trying to make my tangent not go through the curve as quickly. So there's my tangent line. Now they're telling me that the equation of the tangent at x equals 3 is y minus 1 equals negative 1.75 x minus 3. So that tells me something I already could see, that that point of tangency is 3, 1. I see that here from the 3 and the 1. And then I have a slope value of negative 1.75. So what information do we get from this line about the graph of f of x? Well, I already know that my f of x is decreasing at the point 3, 1. So f of x is decreasing. And I know that because f prime of x is less than 0. I also know that it goes through the point 3, 1, as I said. So we don't know enough information to find f of 3.1. So if I tried to approximate that on my graph, I don't have enough detail here to find the exact value of 3.1. I don't know the equation of this curve, but I know that if I zoom in even closer here, so when my x value is 3.1, I know my curve and my line are really close to each other. So I can, because I know the equation of this line, I can find a y value on the blue line when x is 3.1. So let's go back to that. So we can estimate it using the tangent. F of 3.1 is going to be less than f of 3. And I know that because I can see that my function is decreasing. I also know that the derivative at f of 3 is negative. All right, so we can approximate this by plugging 3.1 into my tangent line. So y minus 1 equals negative 1.75, 3.1 minus 3. So that's going to give me, it's going to lead to y being equal to, so this is going to end up being 0.1. When I multiply that, I'll get negative 0.175. So 1 minus, moving that 1 to the other side, 0.175, which is going to be 925. So it is less than the value 1. Now, my approximation is an underestimate, and I know that because my tangent line is under the curve. So it's an underestimate because the tangent is under the curve. I also know that because at that point, my graph is concave up. So I can use this tangent to evaluate x values near the point of tangency, so near 3. But if I extended my tangent line and tried to use it to evaluate, so if I extended this tangent line and wanted to approximate values of other values of x, so if I wanted to approximate my f value when x is 2, that's still pretty close. If I wanted to evaluate when f is -1, using this tangent line would be terrible. I would be off by a whole lot. So I really only want to use values that are near 3. All right. Continuing on, we want to find an x value on the graph where the tangent line approximation is an overestimate. So I could pick any point where my tangent line is going to be above the curve. So for example, when x is -1, let me pick a different color here. So at x equals -1, my tangent's going to be an overestimate. At x equals, let's say, 5.5. Ooh, sorry, 5.5 is an underestimate, not an overestimate, so that's a bad one. Over here, though, at, let's say, x equals 2, I'm going to have an overestimate. I drew it in the wrong place, but let's try that again. Well, all right. So at x equals 2, I would have an overestimate as well. So anywhere that the curve is concave down is going to lead to an overestimate. So concave down for f of x leads to a tangent above f of x, which leads to an overestimate. Of course, this is my answer for 5, not 4. Move that down. Okay. We've already said that underestimates, well, we know that at 3 we had an underestimate, at 4 I would have an underestimate, although actually at 4 I might have an exact value because that's when my tangent is flat. Over at 5 I'm going to have an underestimate. Like I said earlier, at 5.5 I have an underestimate. So anywhere that the function is concave up. So underestimate happens with, I'm going to go back to blue here. This happens when f of x is concave up. All right, f of 1 is 4.5. F prime of 1 is -0.75. Approximate value of 0.99. Well, I know that my tangent line at 1 is going to be y minus 4.5 equals -0.75 times x minus 1. So my approximate value using correct notation, approximately, that's going to be plug in the 0.99, so -0.75 times -0.01 plus 4.5. So this is going to end up being 0.0075, and I could calculate it out, but as we know, we don't need to go any further than that. But here is my approximate value.